if we are dual homed, we may want to influence how traffic comes into my autonomous system from the adjacent autonomous system that I am dual homed into. Dual homed means two links to the same ISP, maybe a primary and a secondary. This is really powerful because we may not have the same bandwidth between us on both of the links. Let's say that the link between R2 and R1 is higher bandwidth than the link between R3 and R1. What we could do is this. We could devalue via the MED. We could devalue the slower link. And we shoot this advertisement out. So if we're making this advertisement, if we're advertising these routes, they're shot out. So now the adjacent autonomous system says, okay, I see that I've got reachability to, let's say, the 172.16 network. I've got a choice. And it looks like the autonomous system path list is the same. So then I go to the next step. So what is it? We love oranges and orange marmalade. This is the last of those. And orange marmalade. So origin, then MED. Also called the metric. So the full name is multi-exit discriminator. The old name is metric. Because this is a metric, or behaves as if it is a metric, we prefer the lower value, because it's like a cost. So we send it to our peers, and that influences how that autonomous system comes into us. They can override this with something like wait if they wanted to. But now the traffic inbound is going to, no, it's not going to go that way. It's going to go through R2 to R1. That autonomous system is going to use the higher speed link as opposed to the slower speed link. So this is a very powerful way of making sure that you're using the proper links between you and an adjacent autonomous system. We can learn a lot from an example such as this, which is going to demonstrate to us how we could influence the multi-exit discriminator. So the goal of this example and this configuration is to say, I want to influence how traffic is coming into my autonomous system from 6500. I want 6500 to go to that subnet through the top pathway. And let's say I'll allow for traffic to go into my autonomous system through the bottom pathway to the other subnet. Now, we're not really modifying anything regarding this other subnet, the .144/28 subnet, but it's a good example to illustrate what we could do. So we could get some load balancing. So this is illustrating how traffic is coming in to my autonomous system from an adjacent ISP. A good example for using the MED. So what I want to do is this. I want to go to Gateway 2, and I want to bump up and devalue the metric for 128. The 128 network. So the default is 0. So I'm going to bump it up by 200, which is going to be devalued. Let's see how to do that. So first, we have a prefix list for that subnet. The way to read that is it's got no LE or GE, so that is an exact single subnet, single prefix match. It has to be a /28, otherwise it's not going to work, and it is a /28, so that's good. Then we go into the sequence, match that prefix, and it's that subnet there. Set the MED, and notice it says metric. That's the other name for MED. In the iOS, it's called metric more often than not. Set it to 200. And then what are we doing with sequence 100 here? well, we're allowing the rest. We're allowing the rest. Then we go back into our config, attach that route map in the outbound direction because we are pushing this to our eBGP neighbor. We're pushing that out, and now the traffic is going to go that way for the 128 subnet. It's going to go the other way for the 144 subnet, assuming that that was how it was previously. So the multi-ex discriminator is very situational. You'd only do it in the situation where you're dual homed and you want to influence how the ISP is coming into you. So your ISP might actually do this to you. If you're dual homed, your ISP might influence the MED to you so that they can control how you're going into their autonomous system.